Hello friends, I am Dr. Vasdev Malhotra, Associate Professor Mechanical Engineering at YMCA University of Science and Technology, Faridabad. I will tell you about the reconfigurable manufacturing systems, which is advanced manufacturing system. What is the system is, what are its benefits, and what are the factors affecting the manufacturing systems, and what are these enablers. This is a very high technique, and advanced manufacturing systems are very used nowadays. Now the question is, what is RMS? The RMS is maybe it may be defined as the manufacturing systems designed at the outset for the rapid changes in the hardware and the software components in order to quickly adjust production capacity within a part family in response to sudden changes in the market or in regulatory requirements. Or in other way, it may be also defined as the RMS is designed for change in structure in order to quickly adjust production capacity and functionality within a part family. And some other means it also may be defined as the RMS is able to rapidly adjust to new circumstances by rearranging and changing its hardware and software components in order to accommodate not only the production of a variety of products but also the new product introduction with the each family. Now, in other way means it is also defined as the reconfigurable systems are designed to maintain a high level of performance by the changing their configuration to meet multiple functional requirements or a change in the operating conditions. The reconfigurable manufacturing systems accommodates potential changes in both the operating environment and the system objectives, creating design with enhanced performance and eliminating the needs of limited design. Basically, the reconfigurations allows adding, removing, or modifying specific process capabilities, controls, software, or machine structure to adjust the production capacity in response to changes, market demands, or technology. For a manufacturing system to be rapidly reconfigurable, the system must possess certain key characteristics. The key characteristics are they includes modularity, design all the systems components, both software and hardware, to be modular. And the second is integrability, which means that design system and components for both rapidly integration and future introduction of new technology. And other one means is convertibility. It means allow quick changeover between existing products and quick system capabilities for future products. Other is diagnosticability, which means that identify quickly the source of quality and reliability problems that occurs in a large systems. And customization, the design, the system capabilities and the flexibilities, basically hardware and the software to match the application of that is known as product family. Now, in what way it to be more specific? I think it to be more specific by the means of dedicated manufacturing systems, flexible manufacturing systems, and after that the reconfigurable manufacturing systems. Now, why we have to need of this RMS? What is the need of RMS? The let us see the cost in DMS dedicated manufacturing system is low as they operate a full capacity. This means that the demands should exceed supply. Furthermore, DMS are not scalable and they have fixed cycle time and capacity. Clearly, DMS does not offer an efficient solution for the current market conditions, but the flexible manufacturing systems, that is RMS, are flexible, scalable system in their support product variety. They are, however, rather complex as they are constructed with all the possible functionality. This level of complexity requires highly skilled personnel to be employed. Although FMS focus on the flexibility, they are obsolete as their hardware and the software are flexibility and they are obsolete. They are fixed nowadays. This means that they are not adequately responsive to change as their capabilities in terms of upgrading, additions, and customizations are limited. Moreover, FMS built up for low or medium volume productivity so that they are suitable for large market fluctuations. The new paradigms needed by the today manufacturing should be incorporate the advantages of the FMS but also with a similar, responsive and less costly. The RMS paradigm attempts to satisfy these requirements and avoid the shortcoming of the previous conventional manufacturing philosophies. Now, the question is that what are the strategic benefits of the RMS? The strategic benefits of the RMS: increase product quality, reduce time required for the product changeover, enhance ease of prototype development, reduction of lead time for launching new manufacturing systems, rapid upgrading of the system, and quick integration of new process technology. Other is what are the tactical benefits of RMS? The tactical benefits of the RMS, that is improved process technology, customized manufacturing policy, improved gap level between manufacturing system and demand variation, adjust machine structure, high scalability, high flexibility, improved quality, improved working conditions, improved manufacturing controls, good monitoring and machine and tools, and other is the good accuracy with reduced setups, adjustable system structures, improved control of parts, improved data management, improved control of operations of a simultaneous tools, increasing frequency of new product introductions due to shorter life cycles. Now, other is the what are the barriers which are affecting the implementation of RMS? That barriers are selection of machine modules. Number one, in this in this case, in RMS, a number of processes are feasible to produce one product. Such processes related to different configurations of different machines. In practice, only one process is adopted to produce a product in accordance with various products to be produced in the same time period using identical resources. The proper machines and processes must be selected from the multiple alternatives. These selection should be contributed to be improved of a certain system performance attributes. Hence, system models should be facilitate decision making in selecting the machines and the processes. Other barriers are the reconfiguration of the controller architecture. The reconfigurable of the controller architecture that is required when the physical machines tool is reconfigurable, unlike dedicated machine tools or CNC controller architectures. The reconfigurable machine tool controller architecture is dynamic. The reconfigurable machines tools may require the integration of an interpolar software module, which is not easy and it is very difficult. Then other is module economy. In the module economy, this is also an important barrier. Most of the variable and the drive units are supplied with the electricity and are connected with the controller by the wires. Some of them also requires hydraulic and compressed air. The location of the hydraulic pumps, compressors and the accumulators is a big barrier for the reconfigurable of the machine units. Other is development of design methodologies. The development of a mathematical framework of a synthesis of reconfigurable machines and their validation in a major barrier. So, for the development of a mathematical theories for synthesis of a reconfigurable machines, which includes development of a formal and unified presentation schemes for the mechanical functions of modules. That is also a very difficult barrier. Other is constraint satisfaction. In RMS, many constraints can be observed. The constraints are inherent in the selection of machines and operations. These constraints are associated with the specific design and the machine capabilities. Other is recoverable of a control systems. The control systems are recoverable by using advanced software and the hardware also modules for development of an open-ended control architectures. Other is difficult control of recoverable machine tool with the multiple tools. Multiple tools are required for a recoverable of a machines, but the movement control of a multiple tools in non-orthogonal direction is difficult. But nowadays, in different strategies are developing for interpolation and control in recoverable machine tools. Other is integration of heterogeneous software and the hardware components. The integration of the software with the hardware components is difficult. I think very difficult because the integration of heterogeneous software and hardware components which are developed by different vendors and at different times, so it becomes the big barrier for the RMS. And the difficulty in axis, other is difficulty in the axis location. Location of the axis in the recoverable machine is not very easy task. If the proper location of the axis is not attained by the machine, then it will result to loss of accuracy, and accuracy is also a very important factor. Then other is control of process variations. As the product variety is associated with the diverse design specifications, as design changes lead to many changes over in processes of producing material item and end products. Such changeover are reflected as variations in machines, operations and the processes. The another is complex systems. In RMS, a number of processes are feasible to produce one product. Such processes lead to different configuration of different machines. In practice also, only one process is adopted to produce a product. In accordance with the various products to be produced in the same time period, using identical resources, the proper machines and the processes must be selected for the multiple alternatives. Other barriers is expensive tooling. The optimize the cost in manufacturing processes, a costing model is required, but the recoverable machines requires expensive tooling. The other barrier is difficult interfaces. It is not so easy to assemble the machines modelers accuracy enough to meet the accuracy requirements of machine tool. The interface between the modules to be assembled must be standardized and accurately manufactured. The other is difficulty variety of the handling. The large number of the individualized products in the RMS investability leading to a high variety of materials items such as raw material work in progress. Since their fulfillment in control focus of RMS, it is essential to capture the high variety of material and end products in the small models. After that, there are some the factors also and affecting the implementation of the RMS. Before this, we have discussed the different barriers which are affecting the RMS, and after that, we have discussed the why the need of that RMS is to be here after the FMS, and now we are discussing the factors affecting the implementation of RMS. One factor is modularity. The modularity may be defined as the production functions and the requirements into operational units that can be manipulated between alternate production schemes to achieve the best arrangements. In recoverable machining system, the major components are modular. Other is integrability. The integrability may be defined as the ability to integrate modules rapidly by a set of mechanical, informational, and control interfaces that enable integrations and communications. The integrations in terms of component interface is concerned with the lowest level of connectability, which forms the basis of the system ability. Another factor is customization. The customization may be defined as it is the ability to be customized in the term of flexibility and the control. The customized flexibility means that machines are built around the product family, integrated controls modules using open architecture technology, which provides the exact control function required achieve customization control. Another is convertibility. Convertibility is the capability of a system to adjust production functionality or change from one product to the other with considerations of cost and time. The convertibility can be system performance measuring for any type of the system. Then other is I think responsiveness. The responsiveness means willingness to help customers, promote service to the customers in relation to the reconfigurable manufacturing system. It is convinced by the incorporation of business analysis techniques which the system level organization and the modeling technique. The another is reliability. The reliability means the ability of a system or a component to perform its required functions under stated conditions for a specified product period of a time. The factor plays a very important role in designing or reconfigurable manufacturing systems. The another is scalability. The scalability is the capability to accurately adjust the production capacity, that is means volume of a system with minimum cost and in minimum time over a large range of capacity. Convertibility and scalability measures are important when considering the responsiveness of a system. Other is flexibility. The flexibility may be defined as the ability to change the adapt to range of a states. Flexibility is the property of a system that allows it to respond to changes in the objectives and the requirements. Other is multifunctionality, and that is you can say fulfill multiple objectives from a fixed set of resources. The need of satisfy multiple objectives may arise from the demand of various varying operating conditions. Another is adaptability. Adaptability also a vital factor for defined as the ability of a system to adapt itself to deliver intended functionality under varying conditions, though the design variable changes their physical values. Now, other is vendor development. The vendor development is one of the vital factor of the static resources, which improves the value received from the suppliers. The vendor development can be defined as an activity that is buying firm undertakes to improve a supplier performance and capabilities to meet the buying firm supply needs. Other is technical knowledge. The technical knowledge is also an important factor in designing of a renewable manufacturing systems. If the worker who know multiple and better working techniques and the skills are available, the major problems in the designs of the RMS may be solved. Then other is manufacturing and the design cost. The cost is also a everyone body knows okay, cost is a vital factor that affects the implementation of renewable manufacturing systems. In order to design a system which design variable changes during operation will result in increased cost. The another is training of staff also. This is also a main important factor. The function of the training is to understand how the system will change manufacturing processes. It is true that training is very important for every staff member to increase the efficiency of the industry. Then after that, team spirit. Team spirit is an essential factor in designing of and reconfigurable manufacturing systems. The team should have mix of consultants and the internal staffs so that the internal staff can develop the necessary technical skills for the designs. During the design processes, it is very necessary that team members should be assigned full time because it is very important. Now we have discussed in this lecture. This lecture was very important. In this lecture, we have discussed regarding RMS. What is that RMS? What is the need of the RMS? What are the strategic benefit of the RMS? What are the tactical benefit of the RMS? Barriers in the implementation of RMS. And in the last, we have also discussed the factors affecting the design of the implementation of RMS. This is the friends. This is regarding RMS. In the further lecture, we will see the different techniques which are in the research purposes we are applied, in what way they are work and what way they are work on the barriers and the factors also. Thank you very much for